Hi everyone, today we'll present our RC surveillance car by Group 1, and we'll talk about team members and roles, description of our car, useful application which it can do, outcomes, community, partners, duration, planning confirmation, our finished part and Gantt chart, and human factors. And once again, our team members, Ahror Abdulkhamidov, he's team leader, engineer, research, and development. And he also started doing this project and chose this project because he had all initial tools to make this car and finish it. And Shohin Abdulkhamidov, his brother, engineer, project manager, and me, Vladislav Semenyutin, engineer and financial advisor. So description of our car. We made a prototype for a remote-controlled car with live surveillance. And also, we can apply different modes to this. For example, we applied a camera for our car, so it is we can make a surveillance. And in future, we're planning. We think that it will be very easy to apply some new modes to this car. And our useful applications are landscape surveillance and secure area surveillance. And initially we made this for security purposes because me and Ahror, we are security guards, and sometimes we need to do the patrols, and we think it would be cool if we could do patrols through this RC cars or drones. And our outcomes. The project will affect scientific research and improve security and good potential for future upgrades and modes. As we said before, we can add lots of modes to this car. We can add, we can make this car to be able to move objects, and we can also add some sensors to this car to improve handling. Community partners. Beneficial for companies who own, create, and distribute this product and in future modes. This product is dedicated for researchers, government, private companies, and general public. And we started this car 2 months ago, and also our first prototype was already ready at July 25th, a week ago. And 2 weeks ago, we finished purchasing all necessary stuff for this car. And 1 week ago, we met at Ahror place and made all final adjustment for this car because we had an issue where our motors, we have 2 motors on this car to turn and to drive forward. And we couldn't make this car to work with 2 motors at the same time. Yeah, but we managed to fix this problem, and our final prototype was ready already yesterday, and it's working good. And planning information. So first of all, we start planning this, and then I ordered materials, which were ready like 2 weeks ago, and testing equipments. Ahror did this on his place, and initial build, he also did this, and testing and finishing field we did together a week ago. We fixed all errors and made a final adjustment. And also presentation was made by Ahror's brothers, Shohin. Yeah.
Okay, now that you heard all that important information about our car, it was like a warm-up. Now let me explain you how does this car actually work. Here is the RC car Arduino sketch. So as you can see, the brain of our car is a Arduino Uno microcontroller, and it has 2 motors, one to accelerate and one to turn wheels. It has also RC receiver with 2 channels. It actually has 6 channels because we bought a flight drone RC receiver and controller, but we used only 2 of them, and it was enough. And all of this is supplied with 9-volt batteries, which I just recently found out it's actually not enough. I need to improve it to 12 volts for better speed. And Of course, the most important part, I think, is the motor driver, L293D. It's a dual bridge motor driver that allows us to properly distribute and control power between two motors. Now, next slide, please. Now, some theoretical background about the motor driver and the power distribution. So the motor driver, it allows us to properly channel enough power for both motors, but there are certain limits with each motor driver, and specifically this one is actually not the best one because its maximum output is 600 milliamps, and so and this is kind of also dependent on the supply voltage. In our case, it's 9 volts. And normally you would think that if you supply on parallel circuits two motors, then both of them going to receive same power because both of them have a same voltage. But that's not the case. In our case, it's actually when you connect one motor and or you use it in full power, it gets its acceleration is at the most. But then if you use two motors at the same time, for example, when you're drifting, then the two motors, each of them, they're gonna get only half of the power. But still, besides that, both motor can work simultaneously. And when you're turning and driving, you don't actually need the maximum acceleration. Now, next slide, please. This is the car itself. It as you can see, it also has a GoPro camera attached to it. That is for live streaming. It now and you can also record videos. Now, next slide. This is our PERT chart, and it's already finished, and different colors means different people, and the gray ones means that we did it together. Next slide. This is our Gantt chart. Also, everything is finished, mostly ahead of time. Next slide. Now, Shohin is going to talk about human factors that we considered and will consider for future models of this project.
So considering human factors is important for the prototype and future models of surveillance RC car. I will be talking about 6 important human factors for this project. Next slide. So one of the important human factors is safety. We need to make sure that it's usage of compatible and tested equipment. It needs occasional maintenance checkups, and we need to make sure consideration of safety hazards like outside protection against damages, waterproof, and environment friendly depends on the model, purpose, and environment. Another important human factor is accessibility. We need to make sure that different training required for different models, but for this project is not required any trainings. But the person has to have for the future model has to have an ability to handle electronics, ability to lift lightweight objects, ability to follow instructions, and this product is accessible for adults of any age, gender, race, ethnicity, and culture. Another important human factor is ease of use. We need to make sure it's product easy to use. It requires pulling switches and pressing buttons on the control and the machine. Requires watching and the live stream to control the device. And future models will be built with maximal ease of use for both commercial and scientific use. Another important human factor is interaction. You need to make sure control is used to control the device remotely. Separate screen is connected to the camera, showing the live stream to control the device. Controller for the prototype is very lightweight and possible to carry and use with just 2 hands. Models designed for security improvement will be able to interact with outside world with features like remote speakers, safety alerts, writing parking tickets, etc. Scientific models will be able to interact with outside environment better, with features like analyze, record, collect, and change. Another important human factor is maintenance. This product requires regular checkups and tests, and its power source easy to replace. Since the prototype wasn't soldered, wires and details are easy to replace, except for the chassis. Future models would require trained professional to repair. Next slide. Another most important human factor is cost. We need to make sure the cost is effective for any model, and it's easily replaceable and rechargeable lithium-ion batteries or similar sources to supply with power. For heavy-sized models, alternative cost-effective energy source might be considered. Does not require multiple people to operate one machine. In conclusion, consideration of human factors will be eventually improve the safety for the people and environment, increase productivity of the work, be profitable and effective, and overall benefit everyone.
All right, thank you. Now you can turn off the screen recording. I'm gonna turn on my video to show you the product. Here it is, and I'm gonna try and drive it. Here's is the controller, by the way. You can see I can drive forward, drive backwards, and while I do that, I can turn wheels. And I can control the speed. That's how it works. Now, the range of this remote controller is pretty high because we are not using a Bluetooth, but we are using an RC control. And the only problem is the battery life. It has a very short battery life, but I can already see how this can be improved. Instead of using 9-volt batteries, we could use a pack of 6. Yeah, pack of 6 of 1.5 volt batteries. Actually, even 8, yes. And even increase the voltage, we would increase the speed, but the maximum voltage I would give for this, it could work with is a 12 volts, no more than that. Overall, what I can say that we learned a lot of things. The first of all is that whatever project you do, you gotta always be prepared, and you need a good planning. You need a hard work, and you need to consider the costs, which we forgot about at the end when we wanted the live stream surveillance. We bought a GoPro camera, but GoPro cameras, they are $300, which I didn't expect. So, but my partner got it for much cheaper somehow. And of course, the last thing I personally learned is the patience. You really have to have lots of patience to do these kinds of projects. Thank you very much. We are done.